Welcome viewers to the exploration of total internal reflection, a fascinating optical phenomenon. Let's consider a semicircular prism and let's draw a line perpendicular to the diameter of the prism and name it N. That line is the normal. The normal is always 90 degrees to the prism. And let's incident a ray of light at this point. The ray of light is known as the incident ray, and the angle between the incident ray and the normal is known as the angle of incidence. And here the ray of light is moving from glass, a denser medium, to air, a less dense medium. And when light moves from a denser medium to a less dense medium, it bends away from the normal. And let's call this light ray the refracted ray. And the phenomenon is known as refraction of light. Refraction of light is the bending of light rays as they pass from one transparent medium into another. And the refraction is due to the fact that the light is moving from one medium to another medium of different densities. And when light moves from one medium to another medium of different densities, its speed changes, causing it to bend. The angle between the normal and the refracted ray is known as the angle of refraction. And now there's going to be a weak reflected ray in the glass, and the laws of reflection holds on the weak reflected ray. That is, the angle of incidence is equal to the angle of reflection. That is the angle between the normal and the weak reflected ray. We are not going to focus much on the weak reflected ray. We are going to focus on the refracted ray more. As the angle of incidence in the denser medium is increased, the angle of refraction in the less dense medium also increases. At a particular angle of incidence in the denser medium, the angle of refraction is 90 degrees. At this point, the refracted ray lies parallel to the boundaries separating the two media. The angle of incidence for this to occur is called critical angle. Critical angle is the angle of incidence in a denser medium for which the angle of refraction in a less dense medium is 90 degrees. If the angle of incidence is increased beyond the critical angle, the light is reflected back into the denser medium. This is what is called total internal reflection. When total internal reflection occurs, all the laws of reflection are obeyed. Total internal reflection occurs when light traveling from a denser medium to a less dense medium is incident at an angle greater than the critical angle. Total internal reflection has various applications in optics and technology. Here are some notable ones. Optical fiber communication. Total internal reflection is the principle behind the functioning of optical fibers. Light signals are transmitted through a fiber by repeatedly undergoing total internal reflection at the interface between the core and cladding of the fiber. This allows for high-speed, low-loss transmission of data over long distances, making optical fibers essential in telecommunication networks. Endoscopes and medical imaging. Total internal reflection is used in endoscopes and other medical imaging devices to transmit light within the body without the need for bulky optical components. This enables minimally invasive procedures for diagnostic and surgical purposes. Mirage formation. While not a technological application, total internal reflection is responsible for the formation of mirages in nature. When light passes from a medium with a higher refractive index to one with a lower refractive index, such as hot air near the ground to cooler air above, it undergoes total internal reflection, creating the illusion of water or objects in the distance. These are just a few examples of how total internal reflection is utilized in various applications across different fields.